Hi students. Now let's start another new chapter today, that is probability. Alright. So we had already permutation and combination chapter. Before starting this probability, I advise you to watch permutation and combination videos properly. More than 8 or 9 lessons are there. You just watch those videos properly. Only then start a probability. Because in one way I can say permutation combination can be taken as a base for probability. Because in permutation combination we have learnt how to count different things in different ways or in special ways to save some time. How to count with some formulae or practically everything we have discussed in a proper way. For probability chapter, counting is very important. I'll tell you how counting is important, in what way we can link up these two, how probability is based on permutation and combination. But before that one, what is the meaning of probability? Let us start from this end. Everything we will learn right from the basics. Alright, so if anybody asks you what is probability, what we will say? We'll say probability means chance, right? Possibility. In some way we can give one or the other meanings, we can search for probability there. But students, I'll tell you, probability is nothing but, in one sentence we can say, probability is nothing but measuring the uncertainty. Remember that one. Measuring the uncertainty, mathematically we call that one as probability. What do you mean by measuring the uncertainty? See, let us learn the concept practically, students, right? So we will go by books only. Bookish knowledge is not sufficient to crack competitive exams. You need to apply that one practically. See, measuring the uncertainty means, for example, you take one coin. I am taking one coin. Let us take this coin is a biased coin, right? Not unbiased. This is biased. What do you mean by biased coin? Both the sides, that is heads, or both sides, that is tails. Let us imagine such a coin. Let us take in this way, both sides, that is tails only. Alright, it is not one side head, one side tail. One side head, one side tail coin is known as unbiased coin, without any partiality, equal possibility. But here I am taking a biased coin. Let us take that both sides, that is tails only. Such a coin is there. Now you are tossing the coin. And if the question is, what is the probability of getting a tails? Alright, if that is the question, simply we answer that the question itself is wrong, because you need to ask me not the probability, what you will get there. I will certainly get tails only. Because when you are tossing a coin, one side is up, other side is down once it reaches the ground. Yes or no? In this case, what is happening here? Both the sides, that is tails only. What you will get after tossing the coin on the top means both the sides, that is tails. Certainly that is tails. There is no question of probability. This is certainty. Certainty means there is no question of any probability. Then what is probability? Suppose if you take a coin which is unbiased. Now I am taking unbiased coin. Unbiased coin means one side heads, other side tails. Now if you toss that coin, and if anybody asks you, what will you get after tossing the coin on the top? Now you need to think it over. Right? Thinking in the sense, how to think over for this one. First of all, you should know what are the various possibilities. Once you toss a coin, being on the top, what are the various possibilities? There are two possibilities. One possibility, they may be heads on the top, or other possibility, tails on the top. So two possibilities are there, means out of two possibilities, these two possibilities are called total number of possible events. Right? Now, out of these two possibilities, getting a tails or getting a heads. Suppose the question is, as I asked you, what is the probability of getting a tails on the top? For example, in the previous case, that was a certainty. 100% you will get tails only because that was a biased coin. Now here in an unbiased case, the all possibilities are heads, maybe tails. Two possibilities are there. Out of these possibilities, getting tails is having one chance. One chance. Because only one time I am tossing the coin. When you are tossing the coin for one time, getting tails, how many chances are there? Means one chance. Out of how many possibilities? Two possibilities. Means the probability of getting a tails is 1 out of 2. If you want to give the answer in terms of percentage, 50% possibility. 50% that is tails. Rest of the 50% it can be heads. Got the clarity? This is called probability. Practically you have to learn the concept in this way. Got it? Now, if you want to give this one in a mathematical way, while we are going in a mathematical way, we should have some terminology for that one. Because every time we cannot explain in this practical way. The terminology is like this. Probability of an event, for any event, whatever it may be. Probability of an event is equal to, right? Desired events, right? This is a number of desired events divided by sample space. Remember this one. Alright, this is the formula generally we use to measure the uncertainty of desired things. Now it is probability of an event is equal to number of desired events. Generally we call it as NE. Number of desired events divided by sample space. What do you mean by sample space and desired events? Simply remember students, sample space is nothing but total possibilities, total number of possibilities is called a sample space. Desired event means what we want actually. Here, what is the probability of getting a tails, right? In a single, what do you call this one? Single toss of a coin, one coin. Single toss, one toss of one coin. What is the probability of getting tails? Now simply we can say that is number of desired events is 1 out of sample space. Got the clarity? This is called finding out probability. Right? Now let us start with this basic example, and one by one we are going to discuss the questions. I'll give you the toughest question in probability. We will go up to that extent. But remember students, this is very important. Probability of an event is equal to number of desired events upon total possible ways. That is called sample space. Alright, now let us discuss some other terminology also in the probability chapter, because once you know the terminology directly or indirectly, the terminology may be useful for us. For that reason, just let us discuss that one. In a nutshell, I'll just tell you what is one term and what is the meaning of that, how to use that one in this chapter. Let us go for that, then we will start questions. Before going for the terminology, let me tell you what type of questions generally we get from probability chapter in competitive exams, particularly exams like bank exams, right? Clerical RPO, then staff selection commission, then CSAT, LIC, GAC, NABARD, RBI, grade B officer. Everywhere they are asking questions from probability in one way or the other way. What type of questions we can expect? So basically I can categorize that one into 5 different types of questions, students. One type of questions, just now we have discussed a small question, problems based on coins, right? Then the second one is problems based on dice, most commonly asked questions, right? Then problems based on cards, pack of cards, or deck of cards. Generally they take 52 cards into consideration, picking up one card at a time. 2 cards, 3 cards or 4 cards, but very logical questions on cards are there. Then even dice also very logical questions are there. Then followed by, generally most commonly in competitive exams they give problems based on this one, what is that, marbles also. Okay, then the fifth one I can take as a miscellaneous questions. Miscellaneous. We discuss one by one, right from the basics to the advanced level, highest difficulty formula. So here I have given you probability of an event is equal to desired event, number of desired event divided by sample space. This is what I have given you. Alright, now let us discuss this one while we are going for the general terms used, general terminology used in mathematics for probability. Apart from this, they generally use the word experiment, random experiment. Random experiment. Let us start with this one, then after that I'll explain you slowly these two also. See, random experiment is nothing but, this is an experiment, right, which is conducted repeatedly but don't give the same result. No unique result will be there. An experiment which is conducted repeatedly does not give the same result every time is called a random experiment. For example, if you are throwing one dice which is numbered 1, 2, 3, 4, 5 and 6 on each side, that is called unbiased dice, right? If you throw one unbiased dice, what happens every time? That does not mean that number 1 will come on the top, or number 2 will come on the top, or 3 or 4, 5 or 6. Anything can come. This type of experiment is called a random experiment. Means every time it may not give a unique result. For example, in a basket, some 10-15 marbles are there, different colors. If you pick up one, right? If you pick up one every time, if you do that experiment repeatedly, every time if you are picking up one, it does not mean that, or there is no guarantee that every time the same marble or ball can be picked up. If you are picking up a card, or 2 cards, or 3 cards from the deck of 52 cards, or from the pack of 52 cards, every time the same card may not be picked up. Yes or no? This type of experiments are called random experiments. Alright, then another term generally they use trial. Trial means performing a random experiment is called trial. Performing a random experiment is called trial, and the outcomes are called events. In the case of what is that, throwing of a die, the outcomes are called events. And hope you must have got the idea, right? Performing one random experiment is called trial. Then, as I told you just now, right, the outcomes are called events. Alright, suppose if you are throwing one unbiased dice, getting 1 on the top is called one event. Getting 2 on the top, 3 on the top, 4 on the top, all these are called different outcomes, right? That outcome is called an event. Performing the random experiment is called trial. In this case, perform the random experiment. When you throw a dice, there is no guarantee that every time you get exactly one same number on the top, for example, right? 1, 2, 3, 4, 5, 6 are numbers. For that reason, result is not unique if you do that experiment repeatedly. That is called a random experiment. Performing the random experiment is called trial. The outcomes are called events. Got the idea, right? These are the basic terminology they use generally in probability chapter. Then the next one, very important one, is called exhaustive events. Remember, this is very important. Exhaustive event or sample space, both are same. Exhaustive event or sample space. Exhaustive events or sample space is nothing but total possible outcomes of a trial. Alright, total possible outcomes of a trial are called exhaustive events or sample space. Both are same. Alright, so now for example, if you are throwing one unbiased dice having 1, 2, 3, 4, 5 and 6 numbers on the different sides of that particular dice. When you are throwing that one, what are the total possible outcomes? Maybe number 1 on the top, number 2, 3, 4, 5, 6. So total 6 possibilities are there. 6 possible outcomes are there. The total possible outcomes are called exhaustive events or sample space. Alright, the next one is this one. What is that? Desired event. Next one is desired event. Right. So desired events or desired outcomes are nothing but the outcomes which we expect. Right? The outcomes which we expect. For example, if you are performing one random experiment, a trial of what? Throwing one unbiased coin, unbiased dice, having 1, 2, 3, 4, 5, 6 numbers. When you are throwing that dice, what is the probability of getting odd number on the top is the question. What is the probability of getting odd number on the top? Here, when you are performing that experiment, random experiment, in that trial, what happens? Total possible outcomes or sample space is 6. From these 6 possible outcomes, what is the probability of getting odd number on the top? So how many odd numbers are there? 1 is odd number, right? 3 is odd number. Then 5 is odd number. So desired, number of desired events in this case, 3. Right? What are those 3? That may be number 1, number 3 or number 5. Right? Out of how many sample space here? That is 6. And those 6 are 1, 2, 3, 4, 5 and 6. Now, what is the probability of getting odd number on the top in a single throw of one unbiased dice? Very clearly my answer is 3 out of 6. Here 6 is called exhaustive events or sample space and 3 is taken as desired events, desired outcomes. Now let us get the first question, students, on your papers. As I have told you in the beginning of this class, I am going to give you very advanced questions in different lessons for probability. Let us start with the first question right from the basics. Now you see, students, already we have discussed one small question as an example with the tossing of one unbiased coin. That's very simple. Sample space or total number of possible outcomes or exhaustive events are only 2. Maybe head, tail, right? Heads or tails, isn't it? But here not only one coin, but there are 2 coins. So when 2 unbiased coins are tossed, what is the probability of getting the following questions? Means in the following cases or following trials, what is the correct answer? This is the question. Now you see, students, the first one is when 2 unbiased coins are tossed, what is the probability of getting heads on both coins is the question. Heads on both coins. First, students, remember always probability of an event mathematically with the formula is equal to number of desired events divided by sample space. Number of desired events divided by sample space. First, while taking the probability, you please find out what is the sample space first. That is the healthy habit while doing this probability questions. Simple, friends. You just take this one. What is the sample space? When 2 unbiased coins are tossed, remember, on one coin it can be heads. On the other coin it can be tails. One possibility, right? And what is the other outcome? Tails, heads. Other outcome. Right? What is the next one? Both the cases, that can be first coin heads, second coin also heads. This one. What is the other possibility? Tails and tails. Remember this one. Alright, so now these are called total possible events, right, or outcomes, or this is called exhaustive events or sample space. Now let us take that one. The sample space is 4, right? Now for all the 6 questions, sample space is 4 only, alright, because 2 unbiased coins are tossed. Now the question, students, heads on both coins, what is the probability of getting that one? Getting heads on both coins, how many desired events can be there from the possible outcomes? From the possible outcomes, getting heads on both the coins, only one case. This is. What is the probability of getting that one is 1 out of 4. 1 upon 4. 1 by 4th probability is there, or 25% probability is there. Got the clarity now? Right. Now the beginners, you should listen to this one carefully or watch the video very, very carefully. Now what is the second question? Here, tails on both coins. Same thing you see, sample space is 4 only. Tails on both coins, from the sample space, tails on both the coins, only one possibility, that is called desired event. Desired outcome is only 1. So now that should be 1 by 4. The same answer for this question. Go for the third one. Heads on one coin, tails on the other coin. Heads on one coin, tails on the other coin. Order they have not given. For that reason, heads on one coin, tails on the other coin. One possibility. Next, heads on one coin, tails on other coin. Right? Here both heads, both tails. These two cannot be taken as desired events. Now here desired events are 2. 2 out of course this denominator is same, 4. Got it? Next, third one. Heads on one coin. That is what. Third one we have done. Now fourth one you see. At least one head coming. Now these 3 questions are important, students. These 3 are very, very important. Basic level questions for like we will go take this one as a foundation for some advanced questions. The words at least, at most are very, very important. I am telling you. At least and at most. Now here they are asking at least one head coming. What do you mean by at least? What do you mean by at most? Should be having crystal clear understanding of that one. See students, at least means minimum. Remember, at least means minimum. Okay, or greater than or equal to. That is. At least means greater than or equal to. That is minimum. Minimum means what is that one? A minimum, a certain point, minimum, more than that one, whatever it may be. At least means minimum. At most means maximum, or less than or equal to. Remember, at least means greater than or equal to. At most means less than or equal to. For example, at least 1. Total 5 outcomes are there, for example. So 7 outcomes are there. At least 1. At least 1 means 1 or more than 1. How many should be counted? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 should be taken for one example where total outcomes are 7. Getting at least 1 means 1 or more than 1. Now we have to ignore 0. No possibility cannot be taken here. Right? The next one is at most, maximum. For example, they have given here at most 5. Right? What do you mean by at most 5? At most 5 means 5 are less than 5. 5 are
What do you mean by
5? Less than or equal to 5? Less than or equal to 5 means that can be 5, 4, 3, 2, 1 and 0. Remember. Alright, so and 0. At the most 5. At most 5. Generally they use at most 5. At most 5 means 5, 4, 3, 2, 1 or 0. Got the clarity? Right. Now let us go for which question we are doing now? The fourth one. Fourth one you say at least one head coming. What do you mean by at least one head? One or more than one head. How many possibilities are there? Anyway, the sample space is 4. Now at least one head. One or more than one. No, now this can be taken. It should be. Except this. Remaining 3 should be taken. Now it should be 3 out of 4. 3 by 4th possibility is there, or probability, 75% probability. Got the idea? Right. Suppose, what if the question is at most one head? Now you see students, previously that was at least one head, now it is at most one head. What do you mean by at most one head? Maximum one head, less than or equal to one heads. So now less than or equal to 1. Here you see students, total 4 possibilities are there. 1, 2, 3, 4. Right? Now at most 1, maximum 1, less than or equal to 1. Less than or equal to 1 means you should consider, very important point, 1 or 0. This is called maximum, that is. At most means maximum, less than or equal to. At least means minimum, greater than or equal to. Got it? Right. Now just count this one. At most one head. At most one head means maximum one head. Maximum 1 means 1 or less than 1 means I should take 1 head. This is counted. Okay. 1 head. This is counted. 2 heads it should not be, because 1 or less than 1. Now observe students. Many students make this mistake. The beginners, I am telling you, watch this carefully. Alright. So here there is no head at all. Yes or no? 0 heads are there. Even this should be counted, because they have asked for at most 1, maximum 1. So maximum 1 means it should be counted. 0 should be taken. Now 1, 2, 3. Again the probability is 3 out of 4. 75% probability. Alright. I am just reiterating students. Remember, at most maximum means, suppose it is at most 1 means less than or equal to 1. In that case 0 should be counted. 0 should be counted, because maximum 1. Maximum 1 means 1 or less than 1. Remember this. Okay? Right. Now go for the next one. At most 2 heads. Another important case here. At most 2 heads means less than or equal to 2 heads. Less than or equal to 2 heads means 2 or 1 or 0. So now I need to count from the sample space. Sample space anyway 4 in number. Next 2 are less than 2 heads. This is counted, because only 1, less than 2. Less than 2 heads counted. Equal to 2 counted. 0 heads counted. 0 also less than 2. Right? At most 2 heads. At most 2 heads means 2 are less than 2. 2 are less than 2 means 1 should be taken. 2 should be counted. 0 heads should be taken. Now in this case the probability is 4 out of 4. What do you mean by 4 out of 4? Getting maximum 2 heads in the toss of, when you toss 2 unbiased coins, getting maximum 2 heads probability is 4 out of 4. What is the conclusion? What is the meaning of that one? 4 out of 4 is nothing but 1. probability 1 is called certainty. Probability 1 is called certainty. So certainly you get that one. At most two heads. At most two heads means 2 are less than 2 heads. 100% you will get it. For that reason only, that is equal to 1. 1 is nothing but certainty. When certainty is there, there is no question of probability. Because probability is measuring the uncertainty. Is called probability. Now when it is certain, there is no question of uncertainty. There is no need to measure that one because that is certain. Got the clarity? Right. So now the next one, that's all. They have given at most 2 heads. Okay. Suppose if they give in this way also, at most 2 tails. Less than or equal to 2 tails. Less than or equal to 2 tails means 1, 2, this is no tail, 3, 4. In that case also, that is a certain event. I hope you must have understood this one, students. Just make a note of this one, alright, and try to get this basic question properly so that I can further go for slowly I'll just take up the second question, students, in your papers. First, read the question. What is the chance, what is the probability that a non-leap year selected randomly will have 53 Mondays? Simple question this one, right? What is the chance, what is the probability that if a non-leap year selected having 53 Mondays is the question. Now we see, students, probability of first of all is equal to number of desired events, right? That is desired events divided by sample space. Yes, sir. First you need to focus on the sample space. What is that? What is the chance that a non-leap year selected randomly will have 53 Mondays? Now choose one non-leap year having 53 Mondays. What is the probability? Alright, now see, students, here as all of us know, every non-leap year is having 52 complete weeks. 52 complete weeks plus 1 odd day, 1 additional day. Total 365 days are there, right? 365 days in a normal year, non-leap year, divided by 7. If you go for that one, that should be 52 weeks, complete weeks, right? When I take up this calendar chapter, I'll give you very clearly. But now, 52 complete weeks plus 1 odd day. Now the question is, what is the probability that it is having 53 Mondays? Now here what is, students, when 52 weeks are there, definitely I can say that in 52 weeks, definitely 52 Mondays are there. 52 Mondays are there. Now the question is, what is the probability of having 53 Mondays is the question. Now you see, students, now this is 1 odd day. Now the question is, this day happening to be Monday, what is the probability for that one? Got the clarity? This additional day, because already 52 Mondays are there, because a normal year 52 weeks plus 1 odd day. 53rd Monday, where can I get that 53rd Monday in terms of this day? Now the question is, what is the probability that this day can be Monday, right? So how many possibilities are there? This one day can be Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, or even Sunday. I don't know that, right? I've picked up it randomly. When I picked up this one randomly, this one day can be any one of these 7 days. For that reason, sample space is equal to 7. Got the clarity, students, right? So this one day happening to be Monday, the sample space, this one day can be any one of these 7 days. For that reason, sample space is 7. Now what is the probability that desired event happening to be Monday? What is the probability that that should be Monday? Now here desired event is only 1. Desired outcome is only 1. Why? I need Monday. How many Mondays can be possible here? Only one Monday is possible. For that reason, it should be this one day happening to be Monday. The probability is 1 out of 7. Alright? The probability is 1 out of 7 because this is only 1. Desired event is only 1. Sample space is 7. This one day can be any one of these 7 days. From these 7 days, happening that one to be Monday is only one desired event. So, 1 out of 7. Got it? Now students, you do the third question. I just changed this question as the third question. What is the chance that a leap year, it's not non-leap year, right? What is the chance that a leap year selected randomly will have 53 Mondays? Now this is your turn, students. Now this task is for you. You try that question. I'm asking you simple question. What is the chance that a leap year selected randomly will have 53 Mondays? Now, got it, students? The right answer is, what is the right answer? It should be 2 out of 7. 2 by 7 is the probability. How is it 2 by 7? Just observe, students. Now, this is a leap year chosen randomly. Every leap year is having 52 weeks and 2 odd days. 2 additional days. Odd day is nothing but a day on a complete week is called odd day. Now here 52 complete weeks and 2 extra additional days are there. Now out of these 2 days, one day should be Monday because they are asking 53 Mondays. In these 52 weeks, definitely 52 Mondays are there. Now out of these 2 days, one day should be Monday. Not should be, one day can be Monday. How many possibilities are there? First of all, desired events. Then go for the probability. Before going for the probability, first count the sample space. What should be the sample space, students? Number I'll write, but here how many are there? This day, these 2 days can be Sunday, Monday, or Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, Saturday, Sunday. Alright, how many are there? 1, 2, 3, 4, 5, 6, 7. These 2 days can be any of these 2 days. Now my question is, out of these 2 days, one should be Monday. What is the probability of getting that one? Now sample space is 7. Now desired events. Desired events, if you take, that is here Sunday, Monday. One day can be Monday. Desired event. Monday, Tuesday. Monday can be Monday. Got it? Now here clearly how many desired events are there? 2. Sample space is 7. So my answer is 2. Now take the fourth question, students. Here it is given a 3-digit number is formed with the digits 1, 3, 6, 4 and 5. Okay. Then what is the probability that the number formed is divisible by 2, not divisible by 2, then divisible by 5. 3 different questions are there. Now students, here I have to use the concept of arrangement or permutation. Alright, so here what is the probability that 3-digit number which is formed from these numbers, right, these 5 numbers, divisible by 2, not divisible by 2, divisible by 5. Let us take the first question, right? First, second or third sample space should be the same. What is that sample space? Sample space means exhaustive events, means total possible possibilities is called a sample space. Total possible outcomes. What are the total possible outcomes? Now you see how many digits are there here? 1, 2, 3, 4, 5. From these 5 digits, using these 5 digits, how many total 3-digit numbers can be formed without any condition? How many 3 digit can be formed? 1, 2, 3. Here, from these 5 digits, any one is filled up here, right? Any one. How many ways? 5 ways. Then 4 ways. Then 3 ways. Or you can directly use the formula, that is NPR, that is 5 from 5 permutation taking 3 at a time. Now that should be, anyway, that should be n factorial. 5 factorial divided by n minus r factorial, 2 factorial. This is the same. Now here it should be 5 into 4 into 3 into 2 factorial. Anyway, so now that should be 60. Sample space is 60. This 60 is common for all the 3 questions. Now I am taking up the first question, students, for you, that is divisible by 2. Now what is to be found out? Desired events are how many? How many such numbers are there which can be formed using these 5 digits? After finding out that number, you need to find out that number is probability out of this one. Got the clarity? Right? Now find out that one divisible by 2. Condition is there. 1, 2, 3. Divisible by 2 means here the units place should be 1 cannot be taken, 3 cannot be taken, 6 or 4. It can be 6 or 4. A 3 digit number, 4 or 5 or 6 digit number ending with, right, 6 or 4 from these digits, right? From these, any 3 digit number or 4 digit number or 5 digit number, because only 5 are there, right? By mistake I have given you 6 also, 5 digits. So any number, whatever it may be, ending with 6 or 4 should be divisible by 2. Anyway, I am finding out 3 digit numbers. So either 6 or 4, it can be filled up. It can be filled up in how many ways? 2 ways. Any one number. Any one number in 2 ways. Alright. Now here, remaining 2 here. These 2 places should be filled up by choosing any 2 digits from the 4. 4 means what is that one? If 4 is utilized here, 4 should not be taken here, because they have not given repeats are allowed. For that reason, we should take it for granted that repeats are not allowed. I have given you very clear picture in permutation combination chapter. Right. Anyway, now it should be taken out of 4. Out of 4, permutation 2 at a time. Or you can take 4 into 3 here. 4 into 3. Now it is 4. This is 4 into 3 into 2. It should be 4 into 3 into 2. That should be 24. Right? Now the probability of getting divisible by 2. Divisible by 2. Total desired events are 24 out of sample space 60. Got the clarity? Right? So now just go for this one. Just simplify this one. Just simplify this one. It should be 12 2s, 12 5s. What is the probability? 2 by 5. Got the clarity? Right? As simple as this one. Now what is the second one? Not divisible by 2. Now students, when it is not divisible by 2, you go by the complementary method. We have discussed even this one in permutation combination chapter. You please refer that one. So complementary means instead of going in the negative way, not divisible by 2, you go for total minus divisible by 2. Total minus divisible by 2 will give you not divisible by 2. Always remember this one. Here in this case, not divisible by 2 is equal to total minus divisible by 2. Alright. Now, how to take it forward? The probability they are asking. What is the probability of not divisible by 2? That should be total minus probability of divisible by 2. They are not asking the number. Here, not divisible by 2 probability means total minus probability of divisible by 2. What is the total? Total means certain. That is 1 minus probability of divisible by 2. That is 2 by 5. Now it should be taken as a 3 by 5. Got the clarity? Right? 5 minus 2, 3 by 5. Now the next attempt, what is the probability of getting divisible by 5? So divisible by 5 means a 3-digit number. I'm writing here 1, 2, 3. Divisible by 5. So from these digits, divisible by 5, that should be ending with 5. Our units place, that should be 5. So digit 5 is only one. So right. So for that reason, I'm taking this one in one way. Now here from 4 permutation 2. Because 5 is utilized here, 5 cannot be taken. 1, 3, 6, 4. Any 2 from this 4 with that arrangement. In this case, that should be 4p2. 4p2 means that should be 4 into 3, this one, into 1. That is 12. Now what is the probability of getting that one? 12 is number of desired events. Right. Divided by sample space 60. Now my answer is going to be 1 out of 5 chances are there. Out of every 5 chances, 1 chance is there for that one. Or 20% probability is there. 1/5 of the probability is there. Hope you must have understood this one, right? What if they ask not divisible by 5? That should be 1 minus 1 by 5. That should be 4 out of 5 possibilities for probability of getting those 3-digit numbers which are not divisible by 5. Many numbers are there. Right? For that reason, that should be 4 chances out of every 5 chances. In that ratio, that will go on.